people use their eyes as a pair, right? So you use them for what's called stereo, where based on the differences between your eyes, you can tell how far away something is from you. And so the robot does the same trick, where it takes two different cameras, and by looking at something from two locations, it can basically see where those two lines intersect, and it knows where in 3D space whatever the thing is that it's looking at is. It also has this that's tilting up and down. What's inside of this is a laser that's spinning around 40 times a second. And the way that this laser works is it sends out a little pulse. It goes until it bounces off of something. So like right now it's bouncing off of the wall, or it's bouncing off of me, and it's coming back. And the electronics inside measures how long it takes for that light to get back, divides that by the speed of light, and then it knows how far away the thing is it's seen. It's a very, very cool piece of technology. So what that lets you do is, if Norway is driving along through here, it can turn around and look at you guys, and you'll see yourself on screen and know that the robot can see you. And let me hand over. This is Gil. Do you want to?
Yeah, I'm Gil. I've been doing we're getting ready to take a bunch of these robots to Alaska and show them off, just like we're showing them off now. So we've been doing a lot of work to sort of show why our robots are cool. And so I'm just going to park it. So Eric sort of already gave you the major part of the tour. Let me move it a little bit more to the side so everybody can see the screen. So the first thing you'll notice is we have the sky that's tilting up and down here. And what that means is that at each given time, it's only getting a two-dimensional slice of the world. It can only see across. So what that looks like. And so this means that we can actually, in addition to doing things like just avoiding things that we can see at the bottom with our 2D scan, this can avoid things like tables. So we can see not just the bottom of the table, but also the actual top of the table by getting a 3D scan of the world. So we can use this to navigate our big robots in rich environments where where there are bunches of things like tables. So the next thing we'll notice is that the robot can actually see itself in these scans. So if I put its arms out, so you can see that it takes us a while to sort of forget our last scans, but the robot's actually seeing its own arms. So but you know, if we're trying to get around the world, we don't want to avoid ourselves. We already know where our arms are, so we can actually use the fact that the robot knows where its arms are in the world to get rid of those points. So this is actually a scan that has had where the robot has said, I know where I am, I'm going to get rid of all those points so that now I can navigate in the world freely.
It's fun, isn't it?
Robot using our visualizer that Gil was showing. I am not as proficient as Gil in moving the viewpoint here without causing seasickness.
As many video games as I do.
So yeah, if you get motion sickness, blame me. I'm sorry for that.
Once it has the stapler in the hand, moving your arm becomes even harder, because normally you could move your arm right over the table. But if you're holding a stapler, if you try to move right over the table, you're going to hit it. So it has to plan a path where it will avoid everything, and also where the stapler will avoid other stuff. So now it's going to look over to the right. It's going to try to find a good free space where it can put the stapler down. So it's building the map of both exactly what's there and also in general what's around it, so it doesn't hit anything. And then it's going to do the path planning back to that.
Is it possible for it to squeeze too hard and break something?
Depending on what it is, that is possible. It's the hands are pretty hard, or the hands are pretty strong. There are sensors that you can put on the fingertips that actually let it know how hard it's squeezing. The sensors are. It has a lot of pretty precise understanding of where things are. So going 2 centimeters away from something versus hitting it is a big difference.
I can hold it still, probably.
That's something wrong with doing. Don't take the wallet and run.
And then I'll click it in. So about there?
Yeah.
And now you're on. the robot.
Ooh, cool.
It looks hard.
It's
Go
okay,
back.
keep trying. Keep go
Then
fast.
how do I spin the thing to make it?
So this front part spins, and then I can open and close you.
Okay, hold on, and I go like this, go down, go. No, I went too far. Okay, keep it there.
Oh, it's not helping. They're moving
Oh.
it around for you.
Yeah.
No, wait, hold
I
on.
think it helps to keep
Stop
it.
moving it,
um,
please.
How about do it horizontally?
Can you
I think
please
he wants to
lift
do
it
the
up?
top.
I can't go down.
Yeah. Yeah.
Lift it up.
Can you ask her to lift up her a little bit higher? Oh no,
Okay.
he
Yeah,
got
there
it.
you go.
Okay.
He got it.
Yeah.
Yay.
Good job. See, you have it. Can you serve the?
Oh, sorry, it's spinning. How come it's spinning? Oh, I think it's because I'm hitting it a bit too much there. Okay, there we go. Then. Oops, sorry. I dropped it.
Okay, yeah. Alright, can we let Joseph try to? You get out of the way.
Okay, I'll open it.
There we go.
Ha. Oh, I didn't know I could do that.
Yeah, you just said so. So can you hear me?
Yep.
Yeah.
Great, I can hear you. So this is a way that you can basically go pretend to be someplace that you aren't actually. You can drive around with it and talk to people, do whatever you want. If any of you wants to come into the next room, you can put your face on the robot, pretend to be a robot driving around.
Oh wait, that's my first time.
Yes, no? Maybe.
You want to go right?
No.
Next room?
Okay, Sadaf gonna go.
Are we going left side or right?
Just talk with me.
Brian, you wanna talk to Sadaf?
He can't see me. The camera.
You wanna talk to him, Brian?
I don't know. I don't really know what to do. I'm just saying how. Oh,
Jeff?
he's moving it.
Oh, he's moving it.
And you see